Okay, hello Year 3 Caesareans. I'm Mr. Ng. I'm the subject head for physics at Sea Douglas. I'm going to do this set of video tutorials to help you uh, to give you a broad overview of what kinematics is about. I understand some of you are struggling. I assure you, do not worry. Every year we have students struggling with kinematics, okay? But eventually, if they work hard, all right, they end up understanding the topic well, all right? So key thing is to persist, all right? Okay, without further ado, I'll quickly start with question 1. Right, distance between Jurong East MRT and Boon Lay is 10 click or 10 kilometers. Average speed is 45 kilometers per hour. Okay, straight away you want to see if you can apply your speed equal distance over time formula. Alright, so the formula you want to use in this question is average speed is total distance over total time. Okay. Okay, so average speed is total distance over total time. Alright, so as the train moves from rest, okay, time taken for a train to reach speed of this, if the acceleration is a constant rate of 3 meters per second square, right? This one, the first problem that you encounter is these two units are not able to multiply with each other. So I need to convert either kilometers per hour to meter per second or vice versa, right? So I will choose always to go for SI units. So I will try and convert this to meter per second. Right, so how do I convert this to meter per second? Right, 35 kilometers per hour can be written as 35 kilometers divided by 1 hour. Alright, I convert the numerator to meters, I convert denominator to seconds. Alright, and I get something like 9.72 meter per second. Alright, so this is the final speed of the train, right? Okay, converted from this value. Alright, so if I know that my formula for acceleration generally is a equal v minus u over t, so I'll just apply that, right? So a equal v minus u over t. Okay, the acceleration is 3. Okay, so this will be 3. Alright, the final speed is given as 9.72. The initial speed is 0 because I start from rest. Alright, and the time taken, I will look for it, and it's something like 3.24 seconds. Okay, right. Okay, if I see a suspicious looking object while traveling at this constant speed, alright, suspicious looking object is 40 meters away. Alright, reaction time is just the time taken from you seeing the object to the driver pressing the brake. Alright, so it takes some time for the driver to respond to the fact that he should be braking. Alright, so the reaction time is just this constant speed multiplied by this time. Alright, again you have to do some unit conversion. 45 kilometers per hour convert to meter per second. I won't do the calculation, I'll show you the answer later. Okay, on the following axis, sketch the speed time graph of the train. Right, during reaction time, the speed will be constant. Right, so the speed time graph will look something like that, constant speed. Okay, and then when they brake, okay, we assume constant rate at braking. Right, so it will look something like that. Alright, again I'll show you the answer, don't need to worry too much. Okay, considering that thinking distance and deceleration of the train applied is 3 meters per second squared, determine if the train will stop in time and avoid hitting the object. Alright, so if I know that the deceleration gradient is 3.0 meter per second squared, alright, how do I know that this is the gradient? It's because the speed time graph's gradient is always acceleration, right? Or in this case, the deceleration's magnitude, which is 3 meter per second squared. Alright, so if I were to look at this question, I want to find out if the train will stop in time before hitting the object, which is 40 meters away. I would like to see if I can calculate how much distance the train travels before it stops, which happens to be the area under the graph for this diagram over here. Alright, so firstly, I know the thinking time is 0.6 here, right, and the speed is 45 kilometers per hour, which I will convert to meter per second at 12.5. Okay, I trust you can do this calculation already. Right, the key thing is I need to know this time. What exactly is this time? Alright, so that I can calculate this area. Alright, so how do I calculate this time? One way is to think about it as the gradient here can be calculated by a equal v minus u over t. Alright, So the A in this context is actually negative because the gradient is negative. Alright, so remember this is minus 3. Can you see this negative gradient? Hopefully you know this is positive gradient, this is 0 gradient, and this is negative gradient. Alright, and then the velocity is actually 0. Alright, the initial speed is actually 12.5. Alright, because this is the initial speed. Okay, I'm just looking at this region. Right, and the time taken is actually what I want to know. Right, so the time taken for this is actually 4.16 seconds. Right, so this time here is 4.16 seconds. Alright, so now I want to find the area under graph for the whole diagram. Right, so area under graph here is just the area of this rectangle. Right, area of this rectangle. Area under graph here is the area of the triangle over here. Okay, so you should be able to get the answer, I believe. Alright, I'm going to just show you the answer. Alright, so that you don't have to worry too much about what the final answer is. Okay, so you can pause and have a look at the answer if you want to. Alright, again, we have already discussed this. Okay, do note that what I calculated was from here to here. Right, so if you want to actually put a number here, it should be actually 4.16 plus 0.6, which is approximately 4.8. That's why the value here is 4.8. Alright, so you can look at the working that's being done. The area under graph, the total area under graph is actually this. Okay, so 26 is the area under the rectangle. Okay, and 7.5 is the area under the triangle. Right, so the total distance traveled by object is 33.5, which is smaller than 40. Therefore, the train will stop in time and avoid hitting the subject or the object.